welcome to Down to Earth. I'm Graham Turnock, Secretary General of Eurisy, and this is the second edition of our webinar that brings you satellite applications and their application to real life. So this is brought to you by Eurisy, which is an association of space agencies dedicated to bringing space applications to new areas of societal activity, and SpaceWatch.Global. So today's webinar is going to be focused on the polar regions with a particular focus on ocean ice monitoring. And I'm delighted to be joined today by two speakers. First of all, by Laurent Bertino. Welcome, Laurent. And just to say, Laurent is a French applied mathematician and research leader at the Nansen Environmental and Remote Sensing Center in Bergen in Norway. He leads the data assimilation group specializing in ocean and sea ice modeling. He's got a PhD in geostatistics from the École des Mines in Paris and has over 20 years experience in data assimilation, ocean modeling and forecasting, especially in the Arctic. And he's been working in particular on the Copernicus Marine Service models and developed the early versions of Topaz, a particularly important model. Also, welcome to David Arthurs. Morning, David.
Morning.
So David is the managing director of PolarView and has been leading that organization for 20 years. PolarView is a global not-for-profit satellite-based data and services organization focusing on the polar regions. David is an expert in Earth observation data, policy, and strategic matters, and he's very active in the polar data community via ESA, the European Space Agency, and other community groups. So the way we're going to run the webinar is we're going to have an interview with each of our guests, and then it's an opportunity for you to put your questions to them. We'll aim to answer those questions in discussion. If we can't answer all of them, then we'll find a way of getting back to you afterwards. We will be recording this webinar. It'll be available online within a day or two on YouTube, and it's also our intention that we'll make shorter versions of the interviews with each of our speakers. So without further ado, I'd like to talk to Laurent in more detail about what you do. So Laurent, could you tell us a little bit about your work and a little bit about why space is so important to it?
Well, my work is, would be meaningless without space data, because what we're doing is, forecast of sea ice, of ocean currents below the ice, and many variables related to, not only sea ice, but the Arctic Ocean in general. And so the context is that there is satellite data, and we want to add more services to that. And the added value is in providing forecasts. For example, the analogy is with the forecast. For example, you would have satellite data, but people want to have the forecast, to have other products that are not the satellite data. I can actually ask you to put the first slide on, which is the Copernicus Marine Viewer as an illustration. Nope, that was another slide. Next one was actually David's slide. Yes, so on that one, that's a viewer. It's just a snapshot from the web page of Copernicus Marine Services, where you see sea ice thickness from a model, and you see ocean temperature, but you could also pick up other variables like wave heights or chlorophyll concentrations. That's multidisciplinary, and that's all coming sooner or later from satellite data.
Right. So how much of that is also from in situ data collection, or is it all from satellite?
Well, it's all blended. So we take everything that is available within a given, time period, and we assimilate that. So my work is data assimilation, and so that we can run the model that has taken in satellite and in situ data and put it all in the same numerical model.
Great. And what we can see on this is presumably sea ice. Is that the sort of white patch towards the top of the model? And then you've got what, ocean temperature through the color changes on the sea sections. Is that right?
Yes. So you see where there's no ice, you see the ocean temperature, but you could also select to see other variables in the ocean.
And what sort of other variables might one want to select with this tool, Laurent?
Currents, if you're interested in drift of objects, there's an ecosystem, simplified ecosystem model running. So you could have the turbidity of the water, or the chlorophyll concentration, or different nutrients in the water. That's all part of the service as well, and wave heights typically.
Great, and this is a forecast as well as a sort of a current visualization and past visualization. Is that right?
Yeah, correct. So we provide a forecast. It was the initial activity, and then on top of that, we also put a reanalysis. So starting from the start of the satellites for us, which is the 90s, running all the way forward to present time to have something that is comparable, so we can judge how the situation is compared to past times.
Great. And how far forward do you forecast?
10 days.
10 days. Great. And what sort of use cases are your models being put to? Who's using them and for what purposes? Do you gather information on that?
So the Mercator company is gathering information, and they send us some summarized reports. So I've checked in the past 3 months, we had 4,000 users, and 100 of them are coming every day to download data. And we don't know, we cannot know all what they're doing, but typically there's drift applications. If there's say an oil spill, or if there's search and rescue, then they will look for the currents coming from systems. And there's people doing coastal modeling, because most of the businesses are on the coast, or the applications are on the coast, and they need boundary conditions because there's no boundaries in the ocean. The water is flowing to the coast, and then yes, there's all sorts of other activities that I would never know of. So we have other activities related to icebergs, but I'll come back to that later, maybe. Yeah.
Great. Okay. Well, do take us on if you've got some more slides that you want to share with us.
Yeah, so for icebergs, there's a project that we're running in collaboration with the ice services that's putting up, a forecast system for icebergs. And we are starting with a sort of individual forecast. So maybe if you switch to the next slide, you can see an example of that. So that's west of Greenland. It's an area where there's not much information about currents. And the icebergs are drifting with the currents. So here you can see a little, series of dots with growing size. That's a tag that's been deployed on an iceberg by a tourist expedition. And so the positions are transmitted on a daily basis. And what you see, that's while the iceberg is moving, is drifting northwards. It's drifting with the currents, so you have an impression of the current patterns. That's from the model forecast in the background. And the other dots, there's plenty of small dots there, a bit faded. That's targets identified from satellite data. That's a product from Copernicus. It's produced by DMI, and they have an automatic detection of icebergs. And you see the likely other icebergs in the area on a given day.
Amazing. So are you using the icebergs partly to judge the ocean currents, or are you looking to use the ocean currents to predict the movement of the icebergs, or maybe it's a bit of both?
Our objective is really to predict the movement of icebergs for people who would be worried about one or another iceberg. Say you're a tourist expedition, you see that there's an iceberg where you want to go, and you would like to know if it still be there in a few days. And so that's the target, but indeed in these areas, the iceberg movements are pretty much the only information we have about the currents. So it can be used also for research, probably.
Excellent. Do you have another slide you want to share with us?
That was it for me.
Great. So maybe we can talk a little bit about, what actually space is doing for you, and what are the potential developments that you're looking forward to, which could enhance the services that you're providing. So are you gathering this data, Brett, you say through the Copernicus system? Which satellites are actually gathering the data?
So we use data from 6 or 7 satellites now. So there's the altimeters for the ocean currents, for the ocean sea surface heights. There's also altimeters provides ice thickness. So we use a blended product, CS2 SMOS with passive microwave and altimeter. There's sea ice drift also from a blend of different satellites, scatterometers and passive microwave. SST, surface temperatures of the ocean, that's also from say a long series of satellites. Ocean color from satellites, same visible channels as well. So for us, yes, the satellites are the alpha and the omega. It's a lot of the information we get in, and we're looking forward to other missions that are say, approved, like SIMR from the Copernicus program as well, that will give us more precise ice concentrations. I forgot to mention the ice concentration, of course. Ice thickness as well in thin ice. There's crystal for the ice thickness in thick ice. And another satellite, polar satellite Roselle, and so in the L-band type of SAR image. And that is likely to give also more precise, more, say, iceberg information in sea ice, because so far the icebergs that I've shown are only, say, detectable outside in open waters, outside of the ice.
Right. So the ice density, well, presumably that's important because you can then make an estimate of how long that iceberg will stick around. Is that why ice density is important, or is there other reasons?
Well, the iceberg, say the ice concentrations, if you detect an iceberg in sea ice, then if the ice is compact, the iceberg will drift with the sea ice. It will not feel the current. It will also only start to move with the currents when the ice is a bit loose and say, like in the marginal ice zone, for example.
Okay, that's really fascinating. And how do you actually feed into the future mission planning? Presumably, those people who are planning future missions, you know, in ESA, in the European Commission, want to know your opinion. Are you part of groups that feed in views on what should be the future priorities?
Yeah, so as say Copernicus provider, I feed into the reports from Mercator that gather, say, the inputs from all of us. We are like 60 providers in Copernicus Marine Services. So that's organized by Mercator as a company. And on the side, ESA also has these candidates for, say, other missions, the research, the Earth Explorer missions. And then I'm part of a group that is called CryoRad, which is going in very low frequency passive microwaves, so that you could, in principle, be able to observe the salinity of the water in cold waters. So, among other things, it also has a sea ice thickness and say the glacier on land. But that's the type of satellite we are working with as for the very long future.
Thank you, Laurent. Well, that was really great. What's I think really nice to hear about is the users. So you talked about tourist ships. I wouldn't necessarily immediately have thought of tourism as being a user of your services, but clearly it is, and I'm sure there are a wide range of users. Indeed, we're going to hear from David in a moment a little bit more about specific use cases. So I think we've got a sense of the complexity of the modeling that needs to go on to understand what's happening and to forecast the future, and the really key, as you say, alpha to omega role that space and satellites have in that. So thank you very much, Laurent. Don't go anywhere. We'll have some questions later, and I'd like to welcome David. So David, could you tell us a little bit more about the context in which you're working? And I can see we've got a little kind of circle going on, so hopefully we haven't lost David. But what we'd really want to hear from David is a little bit more about the context in which he works. What are the challenges that you've been addressing with Polar View, and why is space crucial to addressing those challenges? So David, over to you.
Okay, sure. Well, we're part of an ecosystem of service providers that help maintain the safety of ships in the polar regions. Actually, a lot of what Laurent alluded to is directly relevant to us. We're, I would say, downstream of the types of information that Laurent and his ecosystem is providing. So we've been talking about ships in the polar regions. The issue that we're addressing is the fact that the polar regions are really, really dangerous. They when you're in those regions, you encounter a lot of hazards. It's cold, not surprisingly. It's dark for half the year. The weather is really bad. And added into all of that, you have ice. So you have sea ice, which is seawater that's frozen. And you have icebergs, which is ice that has come off of glaciers on land. And the icebergs are actually quite different from the sea ice in the sense that it's much harder and does its own thing. It's ships, icebreakers can go through sea ice, but they don't want to tackle icebergs. And everybody's probably familiar with the Titanic, which sank as a result of hitting an iceberg at a very southern latitude. It's just off of Boston, which is sort of latitude of Spain. People often don't think of ice being that far south. So you have a very high risk to ships, i.e. to property, to life, and probably really importantly to the environment, because if a ship sinks, it tends to produce oil slicks, and the Arctic is not an environment that takes well to such things. So what we're trying to do is reduce that risk. We work with a whole community of like the National Ice Services. Each of the Arctic countries has people who are dedicated to providing information to ships. And we service a number of industries. Most ships are fishing vessels, which tend to operate near the sea ice, but not in it. Resource extraction, so there are mines in the Arctic, some limited oil production, and so those ships are going back and forth. There are communities in the Arctic, particularly in Greenland and the Canadian Arctic. And so there are ships transporting goods back and forth to those communities. And you mentioned tourism. It's actually on the rise. It's a significant portion of what we do because they want to bring tourists to beautiful places, which tend to be off the beaten track, which means they have very special needs.
Great. Thank you, David. That was very clear. Get a sense of really the risk and the activity that is running that risk. You've got some slides, I think, to illustrate a little bit more in detail what you do. Would you like to go into them?
Sure. Okay. First slide, please. So this is more evocative of the solutions. When we're trying to protect ships, we focus on two things. Preparation, so that the ships have a sense of where they're going, what they're going to encounter, and then providing them better information when they're actually in a tactical situation, when they're encountering ice or trying to avoid ice. So for preparation, the IMO, International Maritime Organization, has created something called the Polar Code, which requires ships to be adequately prepared in many ways. The ships need training, they need to have adequate equipment on board to deal with the situation. They need proper communications, etc. One portion of that is the information that's required. And that's all sorts of information to do with weather, sea state, etc., including sea ice and icebergs. That information on the right there, you have a Danish ice chart. So I said that each of the countries in the Arctic provides ice information. They all collaborate in the form of that information. So this is one example showing sea ice characteristics around Greenland, 2nd of November 2025. So you can see the red shows very high ice concentration, and then there are other colors for different levels of concentration. They also provide information on what's called stage of development, which is a combination of the age of the sea ice and its thickness. and then flow size. So if the ice is broken up, is it broken up into large chunks or small chunks? That information gets distributed to ships in various ways. They can get the information directly from the ice service. On the top left there is a product, a service that my organization provides. It's a web portal that has the ice charts from the ice services plus Earth observation data. And I'll get into the details of that later. And then on the bottom left is an application that a ship would actually have on board. It's produced by a company in Germany called Drift and Noise, and it provides similar information, but in a format that is adequate for ships. And in particular, ships in the Arctic don't see, if you're in the highish Arctic, you don't see polar geosynchronous communication satellites. So bandwidth is a huge problem. It's decreasing due to things like Starlink, but it's still an issue. So with this app, you can control how much data you're downloading.
Amazing. David, can you just tell us what is it that you're adding on to the sort of base services that that Laurent is producing?
Well, we're customizing those services. Laurent provides, and Copernicus in general provides data. We're curating that data so that ships are seeing what they need, where they are, when they're there. We're also providing, for planning purposes, historical data in a format that's specific to what a ship would want to know. So a ship can say, okay, I'm going to be here in 6 weeks. What can I expect based on historical averages? That admittedly is a bit of a concern. With climate change, the past is not necessarily indicative of the future. So we also work with climate forecasts to say, well, how might things change in the future?
Great, thanks, David. That's very clear and very helpful. And then I think you've got another slide to illustrate a little bit more. You said in more depth.
Sure, we can go on to the role of satellites. So we use satellites in a lot of different ways. I think for the purposes of this conversation, we're mostly interested in Earth observation satellites. Our workhorse are SAR, synthetic aperture radar satellites. And we use them because, well, for 3 reasons. One is they see sea ice very clearly. This is an example of a Sentinel-1 image, and the characteristics of the ice pop out. Now, Sentinel-1 is what's called a C-band satellite. That's the frequency of the radar pulse that it's providing. So SAR satellites are active in the sense that they emit radiation. It gets reflected off the ice, and the satellite records what bounces back. Laurent mentioned Roselle, which will be an L-band satellite. There's also X-band, etc. Each frequency band provides different information about the ice, and combining them will be really great when we get more satellites available. But C is sort of an average of them all and is what historically has been used. Now, I said it's an active satellite, so that has 2 other advantages. One is it can see in the dark. It's not relying on visible light, so this works as well in the Arctic winter as it does in the summer. And second, it can penetrate the clouds. And the Arctic and the Antarctic are really cloudy places. And so using visible satellites is a real problem. I might mention that historically, this application was the prime driver of creating SAR satellites. So all the constellations that are there now were primarily put up to service the sea ice services, and those services, National Ice Services, are still among the largest users of Earth observation data.
Great. Thanks very much, David. Can I just check then? So you said you were mainly focused at sort of providing the user end of sort of sea ice forecasting. Are you also integrating directly space data into that process? So are you taking the SAR data alongside what Laurent is producing, or are you basically saying this is one of the key things that goes into Laurent's forecasting?
No, we're downstream of Laurent. So,
yeah.
But having said that, our community uses the satellite images directly. So the National Ice Services have their own feeds of the data. They're dealing in near real-time data. They have experts who look at all of the images plus other data and manually draw the ice charts. Our services take those ice charts, the human analysts, and we provide them to the ships alongside the raw-ish satellite data, so that a ship navigator has the advantage of seeing what a human expert says is there, but they can look at the Earth observation image itself, which may be more detailed, it may be more current, and that helps them make their own decisions. At the end of the day, it's the ship is responsible for its own safety.
Got it. So it's a bit like, I might like to look at, on Google Maps, I might like to look at the optical image, but I might also want the map overlay as well. And with the combination of those things, I've really got an integrated view. That's how I'm understanding it. That's very clear. So what do you see as the opportunities for the future, David, in developing your services further? And what's some of the demand signal that you're getting in terms of the need to develop that?
Well, it's interesting talking to ships about what their needs are. They will always want more information, faster, and they want it free. Those are the three drivers. The free part is interesting, but historically, this information has always been provided as a public service, similar to the weather services that anybody in southern latitudes would want to know before they go out on a trip. The future, I would say, I would focus on two things. First of all, the new EO satellites that Laurent mentioned. Roselle, Crystal, and Simmer are two that the European Union are providing, but we utilize satellites from around the world, and there's lots going on there. An interesting part of the future will definitely be artificial intelligence. Right now, there's a lot of work being done on, in fact, maybe put on the next slide here. As I mentioned, currently creating ice charts is a manual process. So this image shows a SAR satellite in the top left. Those are used via human intervention to create sea ice charts today. And then there's various ways that a ship can calculate the risk to their ship, given the ice class of the ship, through some algorithms. In this case, there's one created by the IMO called Polaris. There is work being done to automate that process. And today, the primary process is through what's called a CNN, convoluted neural network, that interprets the SAR image and rapidly produces something similar to a sea ice chart, which then can be fed to the ships. That's in a beta version at the moment. They're being distributed from the Danish Meteorological Institute through Copernicus, but we're currently, as a community, testing them to see how well they work. There's more research being done at the moment, supported by the European Space Agency, on the use of foundation models, which is a different type of AI that we're seeing how well it will work. But the goal here is to create more accurate, higher resolution, faster, and less expensive ways of getting this this information processed for ships.
Brilliant. Thank you so much, David. That was really excellent. And I think the combination of your and Laurent's presentations, we've had a really great understanding of what's being done to provide users with, very practical information. So we're going to move on to the Q&A session. I think we're going to have one or two questions put up on the screen. So let's see what we've got first. I'm just waiting for the tech people to do that. If it takes a little while, I might start off with my own question. Okay, well, I'm going to ask a question myself in that case. So, I mean, question maybe for you, David, more than Laurent, but I'd be interested in Laurent has a perspective. So, how do you get feedback then from the ship, captains and other users on your service? What methods do you use to find out how they're getting on with using what you produce?
We go through a variety of exercises. So whenever we're developing a new product, we always have some guinea pig ships that we test the new product on. So we'll provide them with new information. We'll talk to them, see what they say. I'd say that's the primary way. We always get feedback when things go wrong. So if our system is down, we get a lot of phone calls and we get to talk to people then. What I will say that an issue with the idea that this is a public service provided by the ice services is that maybe like the weather services, what most end users are not communicating with us daily. That's less so for drift and noise. They actually do talk to their customers on a regular basis. They send people out on the ships. We do talk with the ice navigators a lot. So there's communication within the community. It is a smallish community, so we know a lot of people really well.
I guess that's one of the consequences of providing a service for free. You don't have a sort of contractual relationship with somebody, and if they're paying for something, they may be a little bit more demanding, and you may not necessarily, but you may get a bit more feedback. But that's very interesting. I'm still looking to see whether we're going to get any questions on the screen. I think maybe that isn't. Oh yeah, great. Okay, so question for Laurent. How do maritime operators, for example, tourist boats, I don't know whether you can answer this, Laurent, but integrate the portal into their operational workflows? Very well put question. Are there challenges of actually turning your foresight insights into concrete operational decisions? So one of these tourist ships, how are they actually able to use what you're producing, or are they not actually looking at your product, but something more like what David is producing?
Well, they will all have a system on board. These are modern ships, usually the tourist ship. So they will have, they have to have access to environmental information. That's part of the polar code. They need to know where they're going to. But then how they do that? Well, those who afford it have a modern service where they get, for example, the Polar View service on board, and there's probably other companies that provide different services as well, but they cannot usually access the Copernicus Marine Services directly from board. It's too technically demanding. It's too much traffic, too much download. So I wouldn't see that from my office. There needs to be an intermediate user like David or Driftless Noise was mentioned as well, that have the contact and see how the forecasts are used or not used by the users. But that's I would need to get the feedback from these intermediate users. That's something also that is organized on a yearly basis, but it has to go in these steps. So there are challenges because the forecast will not look like reality. So it takes an expert to interpret what the forecast does and think, okay, the ice will move this way. So you will not see all the features from the SAR image in the forecast. That's not possible as of today's technology. Again, we're working on that with machine learning, but that's not what they will see on their screen today. And then an expert, someone who has experience on board, needs to think of, well, this feature is threatening, it's moving towards us, we better get moving, or something like this.
Thank you, Laurent. That was very clear. David, go on.
Well, I just might pull up that animation. Is that possible?
See if the tech, yeah, looks like they can do it. It's just.
So Laurent mentioned forecasts and what you can see in how much detail you can see in the image, well, in his images. But I'll just show this. This is actually a forecast. So what we've done here is taken a SAR image in the past and applied Laurent's organization's sea ice drift model. And we're warping the SAR image, trying to show what the ice will do in the future. So it's a combination of an EO image with a sea ice drift model, and it's a forecast of what the SAR image might look like in the future. And then we can take an actual SAR image in the future and see if we've got it right. Just
Brilliant.
Apropos of Laurent's comment.
That's really clear and very, very visually engaging. We got a question about emergencies. So do either of you get involved with sort of emergency modeling where there might be a sudden challenge of some sort?
I can start. So this is a good segue to talk about one of the situations of working at either pole, but let's focus on the Arctic because that's where most of the ships are, and what an emergency means. So if you think, if you're a boat and you're in trouble off the coast of France, let's say, who are you going to call? Would you call Canada for help? Probably not. However, if you're in the Canadian Arctic and you have an emergency, the distance from where you are in the Arctic to where the Canadian search and rescue resources are is farther than the distance from Canada to France. The Arctic is really, really big, and there isn't much in the way of resources in most of the Arctic. Russia's a little different. Russia has good infrastructure in its Arctic, but Greenland, Alaska, Canadian Arctic, there's very little, and all of the Canadian SAR resources are located in the south of the country. So emergencies are a big problem. Ships need to be able to fend for themselves for a long period in the matter of days, waiting for resources to get to them. Search and rescue responsibilities are divided up by country. So each country has a defined sector that they're responsible for. And search and rescue on land is different than search and rescue at sea. So they're different resources. To get to the question, the search and rescue resources will use the information from our community. We don't tend to, well, the ice services might be contacted directly. So yes, but I wouldn't say that we're primarily involved in a search and rescue operation. They're pretty good at the SAR SAR in our community is used in two ways. SAR as in the type of satellite, and also to stand for search and rescue. So they know what they're doing. We don't tend to get directly involved.
Thanks, David, and thanks for clarifying the two SARs. I was going to do that if you hadn't. So yeah, for anyone that's still wondering, in the satellite world, it means synthetic aperture radar, and search and rescue, obviously, in the emergency world. Amazing. So I think we've got one last question and perhaps time for it. Yeah, thank you for presenting your use cases. And then Laurent, I think we've got on our website, I should just do a little plug for Eurisy's website. We've got over 300 stories of how satellites have been used to solve real world problems. And we've got the story of how Laurent tracked an iceberg, in fact, in the southern oceans, the Antarctic, that broke up into very small pieces that were too difficult to see from a ship's desk. So do your models assess the structural integrity of icebergs, the likelihood of their carving or fragmenting? Over to you, Laurent.
I believe that the iceberg was in, West Greenland, but in any case, so no, there's no way you can assess that from satellite. So if it's, say, iceberg is big enough to be seen, on the satellite image, and you can see that it's been broken in two pieces, well, that's an information that's useful. But the growlers, the small bits that are usually accompanying the iceberg along its course, that's not cannot be seen on satellite. They barely stick out of the water. It's hard enough to see them from deck. So no, the only thing you can mention is that, well, there's the position of the bigger iceberg that can be seen from satellite, and around it you are likely to encounter some growlers that have drifted slightly off.
Do you have any sense of what the risk might be of fragmentation? I don't know if that's going back to your earlier point about getting better information about density.
I believe David can give a more detailed answer, but the icebergs will be, as long as they're caught in sea ice, they don't degrade much if it's too cold. But if they drift out in warm waters, then they get waves, they get eroded, and then they break off, they degrade. And when they're sufficiently degraded to be unstable, they topple over, they roll over, and that's even more dangerous if you're around. Still, there's we can only give very, very simplified simulations of that with models. There's a large field of research to look into the processes, but there's no information that is available to the public anywhere they can forecast in the future. Yeah.
Thanks, Laurent. Anything you want to add to that, David?
Yeah. So from an operational point of view, the community historically doesn't actually use much EO identification of icebergs. That's actually quite new. The DMI detection has only been around a couple of years. What the ships do is use services like there's something called the International Ice Patrol, which was created after Titanic. They've been around for over 100 years now. And it's a collaboration among a lot of countries. And they fund the United States Coast Guard to monitor where icebergs are. And they're not trying to monitor each individual iceberg. They are monitoring what is known as LOCI, the limit of known ice. So historically, they went out with ships, and then they go out with aircraft, and they're now starting to use Earth observation a lot. But the idea is to say, if you sail south of this line, you will not encounter an iceberg. So, if you go into the iceberg region, you're on your own. We're not going to tell you where the icebergs are, but if you go south of this line that they draw every day, you'll be safe. And since they started doing that, no ship has ever hit an iceberg if they've stayed out of that region. So very successful at doing that. And Earth observation is an important part of that. But no, we're not trying to monitor individual icebergs for all the reasons Laurent just mentioned.
Thank you, David and Laurent. That was very clear. Well, we've run out of time, which is a shame, because I think this is an absolutely fascinating subject, and we could carry on now, I'm sure, for much longer. But I think, thank you both. You've given a really, really interesting insight into the world of polar ice monitoring in particular, but also Laurent's told us a bit more about modeling of the sea and the importance of that, not only to shipping, but to coastal communities. We've heard about the risks. We've heard about how those risks are being managed, the importance of space in it all, and the potential for future development from new satellites and from AI. So really, it's been a really great webinar. Thank you very much, both of you. Just time to say that our next webinar will be on Monday, the 15th of December, when we're going to be focusing on disaster risk management. So a little bit of a link to what we were just talking about at the end there. So look forward to you being with us on that occasion. Once again, thank you to Laurent and David and to all of those in the back office helping produce this webinar, and goodbye from now.
Thanks. Bye.
Thank you.